Example 6. The height, x, in meters of a randomly chosen adult male has a normal distribution with mean mu and variance sigma squared. If 10% of the population have heights greater than 1.8 meters and 5% have heights less than 1.6 meters, find the mean and standard deviation. What is this question saying? So let's try and understand the question before we even try and solve it. What information have we been given? Well, we've been told that x is the height in meters of randomly chosen men, and that x is normally distributed with mean mu and variance sigma squared, right? So if I was to draw this out on a diagram, sorry about this, it's a little hard to draw, yikes. That means I'd have some sort of normal distribution here, my bell curve as per usual, and this would be a mean of mu, and I've got some sort of standard deviation, and I'm told something else. I'm told that if I go up here to 1.8 meters, then bigger than 1.8 meters is what? Well, bigger than 1.8, I've got 10% of the population, or 0.1. And I'm also told that if I go down here to 1.6, then I'm going to have below 1.6, I'd have 5% of the population, and I'm asked to find the mean and standard deviation given this information. Well, just given this information, it's not quite enough actually, because again, let me just phrase this as in algebra. This is just telling us that the probability that x is less than 1.6 is equal to 0.05, and the probability that x is bigger than 1.8 is equal to 0.1. So alone this isn't enough. We can't solve for the mean and standard deviation because quite frankly it doesn't appear here. So what do we do? Well, we instead change this this distribution into one that I do know the mean and standard deviation for, and that is the standardized normal distribution. So that is, if I have a normal distribution with a known mean and a known variance, sorry about my bell curve looking a little funny, say mean of 0 and standard deviation of 1, then I can find out, using my inverse normal function, how many standard deviations it takes to have 10% here and 5% here, right? So that's precisely what I'm going to do. I know how to get something with this, a standard deviation, a mean of 0 and a standard deviation of 1. This is my standardized normal, z. And I know how to get there. I just use the formula z equals to x minus mu over sigma. And that should give me the standardized normal distribution. So what does that mean? Well, that means if I want to find out this value here, and sorry, let me just get rid of that. So z is normal 0, 1. If I want to find out these values, what do I do? Well, I need to use my inverse normal. The probability z is less than, and then I just substitute in 1.6 for x here. 1.6 minus mu over sigma is equal to 0.05. And what can I do with this? Well, then I can go to my graphing calculator. Don't know how much of this you guys can see. Here's my GC, right? And I go to inverse normal. So inverse normal. And I key in what? So this one hasn't got an updated OS, so give me a second to figure out how to work this. Right, so sorry, I figured it out now. We go to inverse normal. And we key in the area that we want, and in this case the area I want is 0.05. That's the probability. And I key in next the mean, which is 0, and then the standard deviation, which is 1, and I push enter, and I get this number, negative 1.645. Negative 1.645. So what does that mean? That means, hold on, lost my place. Here we go. That means that this number here is negative 1.645, or rather, that this distance in here is 1.645 standard deviations below the mean. So this is a number of standard deviations below the mean. Similarly, if we want to find out this one, so in this case, sorry, we find that 1.6 minus mu over sigma equals to negative 1.645. And we also get probability z bigger than, again substituting 1.8 into this expression, 1.8 minus mu over sigma is equal to 0.1. And so this is 1 minus the probability z less than 1.8 minus mu over sigma is equal to 0.1. Again, we need to do this because our inverse normal works on a cumulative distribution function, so we can only work with less than. And so we're looking for the probability that z less than 1.8 minus mu over sigma is equal to 0.9. So again, I can key this into my GC, which I'm going to do. So inverse normal. And my area is 0.9. My mean is 0. My standard deviation 1. And what do I get? I get 1.282. So I go back here. And this turns out then that 1.8 minus mu over sigma is equal to 1.282. So this up here is 1.282 standard deviations from the mean. So actually, I now have everything I need to solve this because, sorry, let me just undo that. How do I undo? I've got this equation here and this equation here. And these two will be enough for me to solve my problem. How? Well, that means I have, just rearranging this, 1.6 is equal to mu minus 1.645 sigma, and 1.8 is equal to mu plus 1.282 sigma. So this is now just a simultaneous equation with two unknowns. In fact, I could make them equal to 0. I can actually substitute these in to my polysimiles app on my GC. So from GC, and let's hope that my GC actually has polysimiles on it. Go to apps. It does, but it's a long way down. And it's got polysimiles 1, so this is a very old OS clearly. So this is a, no, sorry, what are we doing? Simultaneous equation solver. Number of equations 2, number of unknowns 2. And so our equation was, if we look at it, 1 mu minus 1.645 sigma is equal to 1.6. So 1 mu, yep, can't quite see the minus sign, sorry, negative 1.645 sigma equals to 1.6, and 1 mu plus 1.282 sigma is equal to 1.8. And we can solve this. Which is taking a long time apparently. I hope yours is faster. And we get x1, which was our mu, to be 1.71, and our x2, which was our sigma, to be 0.683. So from GC, we're able to get mu equals to 1.71 and sigma equals to 0.0683. So what did we do with this question? The important thing to note is because we got all this information at the start, right? But we didn't know what to do with it. What we needed to do is transform it to to a standardized normal distribution. And then I can tell how far from the mean in terms of standard deviations I would need to travel before only 5% of my population was below that amount or 10% above that amount. And once I've got that information, I then had two equations with two unknowns that I could solve simultaneously. And that gives me the answer. Any questions, please post them in the comments section. I'll be more than happy to try and answer them for you.